We're going to take some time to look at several different kinds of equations. For example, we're going to look at some equations which don't look like quadratic equations, but they actually are quadratic equations. But first, we're going to maybe mention a couple different types of equations. For instance, we'll take a look at a new technique a little bit later. It is okay to square both sides of an equation, but be sure to check for false solutions at the end. You'll see this occur. All right, so let's try solving this equation, 2 over x minus 3 plus 2 over x is equal to 3. This is an equation with fractions, so the easiest thing to do, the fastest thing to do, rather, always is to multiply both sides by the LCD. This is always the fastest thing to do when you have an equation with fractions. People sometimes still want to focus on creating a common denominator or something like that, and you can do that, but if you go with the common denominator approach, you're telling yourself that you're going to write more lines with fractions in them, but as quick as possible to get rid of fractions, you multiply both sides by this LCD, and then this x times x minus 3 is written by each of the two fractions on the left, right? So x times x minus 3 times the first fraction plus x times x minus 3 times the second fraction equals 3 times quantity x minus 3. Then on the left side, in the first term, before the plus sign, your x minus 3 on top and bottom cancel. And in the second term, your x factor on top and bottom cancel. So you're left with 2 times x plus, and then for the next term, 2 times x minus 3 equals, and then on the other side, if we distribute the 3x, we'll have 3x squared minus 9x. We can distribute the 2 on the left, maybe do a little bit of collecting like terms, and it looks like we're going to have a quadratic. So adding and subtracting terms on both sides to have a 0 on one side will look like this. I think it'll help us if we just kind of swap the sides and take this to the beginning of the next slide. So at the top of the next slide, let's have 3x squared minus 13x plus 6 equals 0. Okay, and if we're going to complete the square, let's subtract 6 on both sides. Now there is, before looking at the linear coefficient and things like that, we have to take care of the 3 in front of x squared, so divide both sides by 3. As written, nothing will cancel, but we can split up the left side to be two separate fractions. And now that the minus sign isn't inside a fraction, but it's rather between two fractions, we can cancel. So we'll have x squared minus 13 thirds x is equal to negative 2. Now we can compute the second stick is negative 13 over 6, but then the square of that number is what we need to add to both sides. So we'll add 169 over 36 to both sides. On the right side, that is 169 over 36, and then in anticipation of the fact that we're going to need to simplify the subtraction, instead of writing minus 2, I turned that minus 2 over 1 into a minus 72 over 36. The left side should factor, as x plus second stick squared, so that would be x minus 13/6 quantity squared, and on the right side you'll have 97 over 36. Now square root both sides. On the right side, we can split up the radicals, so you have root 97 over root 36, but instead of writing root 36, you'll see just the 6 there. And then to solve for x, we just need to add 13/6 on both sides. Okay, so this equation, at least at the start, was just an equation with fractions, and it didn't look like it was going to be a quadratic equation, but we saw that completing the square worked, meaning that eventually we did somewhere along the line have a quadratic equation. Now let's take a look at solving x squared minus 3x squared minus 2x plus 6 equals 0. So out of the first two terms, you can factor an x squared. Out of the next two terms, you can factor out a negative 2. And then you'll notice that both the term in front of the minus sign and the term after minus sign, both of the terms have a factor of x minus 3, so we can factor that out. So we applied factoring by grouping. We have quantity x squared minus 2 times quantity x minus 3 equals 0, and we can now apply the zero product property. Add a constant to both sides, so add 2 to both sides of the first equation, add 3 to both sides of the next equation. And to the x squared equals 2 equation, we just need to square root both sides. That is going to introduce a plus or minus sign. So we have 3 total numbers in the end. So there's x equals plus root 2, there's x equals minus root 2, there's also x equals 3. I think the key point of this question is just to say, this wasn't a quadratic equation. The degree was actually higher, was a 3. But the thing is, if you see 4 terms, please consider factoring by grouping. Back to an old strategy. Okay, this one looks a little strange. Let's solve x to the 5 halves power equals x to the 1 half power. So I'd like to start by subtracting on both sides, having a 0 on one side, and the only reason to really want to have a 0 on one side is because we want to apply the zero product property. Now, as written on the left side, that's not a product. We will get a difference because it's something minus another thing. So we need a factor. And what we need to factor out is an x to the 1 half. So x to the 1 half, and then in parentheses, something minus 1. That x to the 4 halves maybe looks a little funny as written, but just the comment you see off to the side is x to the 1 half. If you were to distribute x to the 1 half, you have x to the 1 half times x to the 4 halves. And when you multiply things with the same base, you'd have to add the exponent. So that 1 half plus 4 halves is 5 halves. And that's why there's a 4 halves written here. We can go ahead and just simplify the 4 halves in the exponent to a 2, though. And now we can apply the zero product property. So x to the 1 half was one factor, that's set equal to 0. And then x squared minus 1, that's the other factor, that's set equal to 0. You can rewrite the x to the 1 half as a root x. And then for the equation x squared minus 1 equals 0, just added 1 to both sides. Now for the first equation, we're going to need to square both sides. So you get x is equal to 0 squared. For the second equation, you're going to need to square root both sides. That's going to introduce a plus or minus sign. If we simplify, sorry, this should have been on the next line, x equals 0. And then x equals plus or minus 1, because root 1 simplified to just a 1. So it's tempting to start this equation by dividing both sides by x to the 1 half. But if you did that, you'd end up just losing the x to the 0, x equals 0 solution. So in general, please avoid dividing both sides by a variable, or even any expression containing a variable, such as x to the 1 half. Because doing that, you may end up losing a solution. So instead, get all terms on one side and then factor.